Okay, so we just discussed some very interesting relationships of some trigonometric functions, sine, cosine, tangent, cosecant, secant, and cotangent. And now let's try some examples about how we can relate them. So there are some triangles that I really like to discuss that have some unique relationships. And you're going to see them eventually in this thing called the unit circle. And I think it's important for us to dialogue about them. So let's go ahead and look at these, and I'll erase that extra little bit we have. So let's go ahead and look at this one. So let us assume here that's a 90-degree angle. This will say is 45 degrees, and therefore this has to be 45 degrees. And I'm going to use degrees right now there, but this is also known as pi over 4, and this is known as pi over 4. So they are two different ways. I just don't like writing 4 using my program. Sometimes the 4s connect like it did there. I wish I knew how to turn that off. So this is a 45, 90-degree triangle. There's a relationship, a unique relationship between the legs and the hypotenuse of a 45, 90-degree triangle, and that is the relationship of 1 square roots of 2. 1 square roots of 2. So that's a very unique relationship. If we talk about some of our trig identities, they also have a very consistent relationship as well. So if we look at sine of pi over 4, and if we look at cosine of pi over 4, and then we look at tangent of pi over 4. So sine, cosine, and tangent have very unique relationships. Remember, sine is opposite over hypotenuse, SOH, S-O-H. So we're going to relate the opposite. The opposite of this is going to be a value of 1. And we are going to divide that by the hypotenuse, and the hypotenuse is the longest leg of the triangle, and that's going to be 1 over square root of 2. But we never want to have, it's not proper for us to have a root in the denominator, so we can rationalize the denominator by multiplying by square root of 2. So we say sine of pi over 4 is square root of 2 all over 2. Cosine of pi over 4 is, cosine is adjacent over hypotenuse. So the adjacent value is this one down here. So that's also going to be a 1 all over the hypotenuse, which is that square root of 2. And we want to rationalize that and say that's square root of 2 over 2. And tangent by definition is going to be opposite over adjacent. So Tom's old aunt sat on her coffin and howled. That's how I like to remember this. So now if we look at this, our opposite value is going to be 1 over our adjacent value is also a value of 1. So tangent of pi over 4 is going to be equal to a value of 1. So if we want to evaluate if we want to evaluate the inverse of sine, so the inverse of sine of pi over 4, which would be the cosecant of pi over 4. That's the way we relate cosecant and sine, is that they are the inverses of each other. So if we took sine and we inverted sine, the relationship of the sine is that we will have the opposite over the hypotenuse. So I'll write that over here, opposite divided by the hypotenuse. If we invert this, then we know we're going to have the hypotenuse over the opposite. So the hypotenuse is going to be square root of 2 over the opposite, which is just a value of 1. So we're just going to have the cosecant of pi over 4, which is just a value of root 2, square root of 2. If we look at 1 divided by cosine of pi over 4, that's going to be equal to the secant of pi over 4. And notice if I invert these two values, which is the same thing as me inverting these two values, I'm going to have the same thing as square root of 2. And lastly, if I invert tangent of pi over 4, that's the same thing as me saying cotangent of pi over 4. And if we invert this is just going to be 1 over 1. So that's a really easy way for me to remember it. I just think about sine and cosecant. I think about sine and cosecant, cosine and secant, tangent and cotangent. So some people might say, oh, I get confused. I used to think, I look at the C's and the S's. This C will correspond to this S. So sine and cosecant will correspond. Secant and sine will never correspond because they have the same value. Secant and cosine correspond because they're opposite. They are C and S. And then cotangent and tangent, I think that's a little bit easier just because they both end in tangent. So they're usually a little bit easier for us to understand and memorize. So all of our angles dealing with pi over 4, 45 degrees are very important. The same thing goes for triangles or angles of 30 and 60 degree nature. So if we think about this, if this is a value of 30 degrees This is a value of 90. That has to make this a value of 60 degrees. And if we look at this, we can call this pi divided by 6, and this is pi divided by 3. Pi over 3 radians is synonymous with 60 degrees. 30 degrees is pi over 6, and I'm sure most of us recognize that pi over 2 is 90 degrees. So in this circumstance, they have a very unique relationship that this always has a 1 to square root of 3 relationship, where we recognize that the hypotenuse must always be the longest of the values. So 2 is larger than square root of 3. So we have to make this value a value of 2. 1 corresponds to the 30-degree angle, so that's going to be a value of 1. And this square root of 3 will correspond to the medium angle, which is, or the medium, or the angle which falls between the other two, 30 and 90. I don't want to really say medium angle, but that will be square root of 3. So they always have this very unique relationship. So let's go ahead and define. I'm going to do sine, cosine, and tangent. I'll let you guys do cosecant, secant, and cotangent now that you know how to do it. But let's go ahead now and define the the sine of pi over 6, the cosine of pi over 6, and the tangent of pi over 6. So sine of pi over 6 by definition is going to be opposite over hypotenuse. So pi over 6 is 30. The opposite here is going to be a value of 1 over the hypotenuse, which is a value of 2. So the sine of pi over 6 with the sine of 30 degrees is 1/2. Cosine of pi over 6 is going to be the adjacent over the hypotenuse. So the adjacent to 30 degrees is what attaches to that angle, or what's below that angle in this circumstance. So we're going to have square root of 3 all over the hypotenuse, which is still that value of 2. So the cosine of pi over 6 is still square root of 3 over 2. And then the tangent of pi over 6 is still opposite over adjacent. So the opposite is going to be 1 over the adjacent, which is going to be square root of 3. So we have 1 divided by square root of 3, which rationalizes to square root of 3 all over 3. So tangent of pi over 6 is the opposite over the adjacent. So now let's go ahead and analyze pi's over 3, which is also 60 degrees. So let's look at sine of pi over 3, cosine of pi over 3, and tangent of pi over 3. So sine of pi over 3 is going to be opposite over the hypotenuse. The opposite of 60 degrees is square root of 3. And the hypotenuse is a value of 2. Cosine of 60 degrees is going to be the adjacent, because this is adjacent to the angle, over, and that's going to be a value of 1. And this is going to be over the hypotenuse, which is going to give you a value of 1/2. And then lastly, tangent of pi over 3. Okay, tangent is going to be the opposite. The opposite of the 60 is going to be square root of 3 over the adjacent, which is going to be that the value of 1. So here we get the opposite, tangent of pi over 3. I'm sorry, I wrote that backwards. Tangent of pi over 3, actually no I didn't, is the opposite, which is square root of 3 over the adjacent, which is a value of 1. So we recognize here that we have some similar outcomes. Notice here that the 1/2 and 1/2 here exist between sine of pi over 6 and cosine, and we're going to show a relationship of this later. So these two are the same. Notice these two are the same, and these guys are slightly different. The tangent of pi over 6 and the tangent of pi over 3 are slightly different, but we're going to show how this works a little bit later with these relationships.